Today, I'll show you an experiment on bridge rectifier. So before doing an conduction on bridge rectifier, let me give the definition of rectifier and what are the different types of rectifiers and why we need rectifier. The rectifier is an electronic component, or you can also say the rectifier is an electronic circuit which converts AC voltage into DC voltage. So it is the main part of our DC regulated power supply. So it is used, the power supply in many devices we use. It acts as, it takes the crucial part, rectifier. So there are two types of rectifiers, half wave rectifier, another one is full wave rectifier. So half wave rectifier means only during positive half cycle, we will get the output. During negative half cycle, there is no output. So to get output in positive half cycle, we are connecting only one diode. That is half wave rectifier. So rectification takes place only during positive half cycle. So it is called as a half wave rectifier. In full wave rectifier, there are two types, center tap full wave rectifier and bridge rectifier. In center tap full wave rectifier, we use center tapped transformer. But in bridge rectifier, we don't use center tapped transformer. We use the normal transformer, that is 12012 transformer, or we don't require the center tap transformer, but we need 4 diodes which are connected in the bridge format. So bridge rectifier, I'll explain with the circuit diagram later. So why we need rectifier? So can you tell me what is this diagram? This is a mobile charger. See, mobile is connected to a charger. So when you plug your mobile phone charger into the wall socket. This is a wall socket. When you plug your charger into the wall socket, the electricity which is coming from this wall socket is a alternating current. But your phone needs DC current to charge its battery. So there is battery inside a mobile. So this needs a DC current to charge the battery. So inside the charger, there is a component called as rectifier. So which converts the AC power which is coming from the wall socket and converted into a DC power which is required by the mobile. So this is our mobile charger. Input is AC and output is DC. This DC is given to charge the battery of our mobile. See, in this way, the battery charging is taking place. This is one example. The second example is when, for example, TV. So when you plug your TV into the wall socket, the electricity which is coming from the wall socket is again alternating current. But many of the internal components of your TV, such as display and various electronic circuits, they all require a DC current to operate properly. So inside TV, there is a component called as rectifier, which converts AC power from the wall socket and into a DC power. So for this purpose, we require a rectifier. This is need of rectifiers. Two examples I have given. You can give many examples like washing machine, fridge. The many electronic circuits of the fridge requires a DC supply for its operation. Your laptop, TV, they almost all electronic devices require DC power supply for their operation. So to get DC power supply, we use rectifiers. So today we are going to conduct an experiment on a bridge rectifier. So why it is called bridge? So this rectifier requires 4 diodes. They are connected in the form of a bridge. See, this is in the form of a bridge. D1, D2, D3, D4. There are 4 diodes. They are connected in the bridge format. And we need a resistor to get a DC voltage. So resistor must be connected here. So how to do the connection? The anode of the first diode and anode of the fourth diode, they are connected at one point. Cathode of D2 diode and cathode of D3, they are connected at one point. From this point, resistor one end is connected, other end of the resistor is connected to the anode of D1 and anode of D4. The cathode of D1 and anode of D2, it is connected to one terminal of the transformer, and cathode of D4 and anode of D3, it is connected to other terminal of the transformer. If you feel very difficult to draw this diagram or do the connection, this is a simple way of writing the bridge circuit. Very easy. Input side, transformer. So just you connect two diodes in this direction, D1, D2, and below D4, D3. All are going in one direction from left to right. Anode, cathode, anode, cathode, anode, cathode, anode, cathode. And anode of D1 and anode of D2, you take one wire and make the connection here. Cathode of D2 and cathode of D3, take one more wire and do the connection here. And between these 2 points, you connect one resistor. And between this junction, you take one wire and connect it to the transformer. And between this junction, take one more wire and connect it to the junction. So it looks like this. See, I have connected like this. So how to do the connection, I'll show you now. See here, this is my diode 1, diode 2, this is diode 4, and this is diode 3. Anode of, there is a white bar here, the ring, it indicates the cathode. All the diodes have the white bar here, which indicates the cathode. So the first terminal is anode. The anode is, you place it in one point on the breadboard, and cathode anywhere on the other point on the breadboard. Then anode of D2, this is anode of D2, it goes to the same point on the breadboard, and cathode on the some other point on the breadboard. So below this bifurcation line or a separation line, come down, take one more diode, that is D4. Anode of the D4, you connect it to one point on the breadboard, and cathode of D4 to some other point. Anode of D3, you connect on the same point on the breadboard, and cathode to some other point. But we need anode, both together should be connected. Take one small wire. This is anode of D4, and this is anode of D1. So from here to here, you make one connection. So then it means anode of D1 and anode of D4 both are connected to each other. Similarly, cathode of D2 is here, cathode of D3 is here. Take one small wire, connect between this point and this point. It means that cathode of D2 and cathode of D3, they are connected to each other. And between this point, anode, where is that point? This point. And where is cathode? This point. Between these 2 points, you connect 1 kilo ohm resistor. That's all. So this is a very simple connection. If you follow this circuit, so you will not do any mistake while doing the connection. 2 diodes above the separation line on the breadboard, 2 diodes below the separation on the breadboard, same direction, anode, cathode, anode, cathode, anode, cathode, anode, cathode. So these 2 should be come on one point. These 2 should come on one point, and this with wire, this and this with wire, and between this there is a resistor. This is small connection. After this, we should connect the transformer. How the transformer is connected? See here, the transformer is connected between cathode and anode, and below also cathode and anode. Where is cathode and anode point? This is cathode and this is anode point. From here to, it goes to transformer, and from here also it goes to transformer. See here, transformer one end goes to this point, transformer other end goes to this point, the combination of this. So this is all about connection. So from the input of the transformer, we get a sinusoidal AC signal, and the output is DC, and it is not pure DC, it is a pulsating DC. This is the image I have got it from the CRO, input waveform and output waveform. So this much you should show it in a examination. So here I have neatly given the procedure, how to do the connection. Whatever I have explained now on the all the points I have written here. So you follow all these steps. So you will not do any mistake. Positive AC input, negative AC input, bridge connections, load connection. So all these connections you do it. So finally you write the result. So we get pulsating DC voltage across 1 kilo ohm resistor. So which will demonstrate the operation of full wave bridge rectifier. So this is all about the aim, apparatus required, and procedure and the result and the connect circuit diagram. So aim and apparatus I have not explained. Aim is to construct full wave bridge rectifier circuit using 12012 transformer. You can also use 909 transformer also, and 1N4007 diodes. You can also use 1N4001 diodes, and observe the rectification of AC voltage to pulsating DC. Apparatus required 12012 transformer, IN40074 diodes, breadboard, connecting wires, 1 kilo ohm resistor. To see the waveform, to check the waveform, we need oscilloscope. If you don't have oscilloscope, you can check the DC voltage in multimeter also. And DC power supply is not required. For testing, I am requiring. So I'll remove this. So oscilloscope. So these are the apparatus required to do this experiment. Let's conduct an experiment on bridge rectifier. So this is a easy method of connecting the diodes in a bridge format. So D1, D2, D3 and D4, and this is transformer. For this experiment we need components: 1N4007 diodes, 1 kilo ohm resistor and few connecting wires, and one transformer and a breadboard. Anode and cathode of the diode we are connecting on the breadboard, and the second diode anode must be connected to the first diode cathode. So the above connection is over. Now she is doing the bottom connection, the third diode on two different points, and the fourth diode anode is connected to the cathode of the third diode. Circuit diagram: anode and anode must be shorted. Take a small wire and do the connection between anode and anode. Anode of the first diode and anode of the third diode. And cathode must be shorted. Cathode of the second diode and cathode of the fourth diode, they are shorted. And we should connect on the other point on the breadboard. Register on another 2 points on the breadboard. See the connection: one end of the resistor goes to anode terminal and other end of the resistor go to cathode terminal. So take two small wires. One end of the resistor connect to anode terminal. Here anode, and other end of the resistor we should connect it to cathode terminal. Other end of resistor to cathode connection, where we have done, here we have done cathode. Okay, now connection is over. Now we will connect the transformer. This is a transformer. So don't use 12, this is 12 0 12 transformer. Don't use 12 and 12 points. 12 and 0 connection you do it. The first 12 point, this one, you connect it to here. Cathode and anode both are shorted. Now to this point you give. Okay. So another middle one, give it to the other anode and cathode connection. So this transformer connection is over. Transformer is connected to the power supply, AC 230 volts 50 Hz power supply, and this is the cable for CRO. We are using channel 1 for the CRO connection. Now all are on the output open side. keep this in extreme left, extreme left, extreme left, extreme left. Now we will check the input. We should check input at these 2 points where cathode and cathode anode connection. There we will keep the CRO. So we will check whether the input we are getting or not. Cathode and anode connection is here. One is here, another one is here. We'll check the output. This is a input signal what we are getting on the CRO. Now we will check the output across the resistor. We will keep the CRO terminals across the resistor. We will check the output now. This is the output of full wave bridge rectifier in both the half cycle. While checking output, the positive of CRO and negative of CRO both should not touch each other. So they should be separate and connect the CRO terminals across the resistor. We will get the output of full wave bridge rectifier. This is the output of full wave bridge rectifier. In both the half cycles we are getting the output. Make sure all these 3 terminals, secondary output terminals of transformer, they should not touch each other. So one wire you keep this side aside and the middle one and on the first one you use it. We tried with the first and last, the resistor is getting heat. That's why we used the center and the first one.